So for topic number 1, we want to figure out how to integrate products of our first combination, which is sine and cosine, namely powers of those sine and cosine. So it'll be an integral of sine to some power times cosine of some power. All right, now these aren't hard and fast. These are just techniques you can use and try. So, but they usually should work. There are times where a couple of them will actually work, and it's up to you to choose whichever one you like. So if m, the sine power is odd, and n is a real number, you could try strategy 1. If n, the power of cosine, is odd and m is real, then you could try number 2. If m and n are both even, non-negative integers, then you try number 3. All right, so let's look here. So we have, this is number 1, right? M is odd because m is 3. Right here, you can see it. M is 3, which is odd, and n is 3/2, which is real. That's a real number. So we're going to use technique number 1 here. Okay. All right, so according to this, we are going to split off sine of x and rewrite the resulting even power of sine of x in terms of cosine of x, and then use u equals cosine of x. Okay. So we rewrite it. We take a sine of x, we split it off from the sine cubed. So we take one of them out. And then we have a sine squared x left over. And then it's times cosine to the 3/2 of x dx. And then we will rewrite the sine right here, right there. Rewrite sine squared with the Pythagorean identity. So the Pythagorean identity will let us rewrite that one. So it would be equal to the integral of sine of x, and then I would rewrite this as 1 minus cosine squared of x, because sine squared plus cosine squared is equal to 1, times the cosine to the 3/2 of x. Okay, now it might be looking worse than what we started with, I know, but it's doing all right. You just have to trust the process. All right, so that's sine of x times, and I'm going to distribute cosine to the 3/2 of x times both of these. So cosine times 1 is just cosine. So cosine to the 3/2 of x, no problem. And then this one I'm going to multiply and add the powers. So that's 2 plus 3/2. So in other words, that's 4 over 2 plus 3 over 2, which is 7 over 2. So it's cosine to the 7/2 of x, like that. Now, technically, we could have used u sub a step earlier if we wanted to, or we could use it right now, but I wanted to wait until I got to this point. So then u would be cosine of x. I mean, they tell us that right in the method. They say use cosine of x. So I did. Then the derivative would be sine of x dx, which is why I broke off that sine of x in the first place. Kind of make that work. All right, then what do I have? If I rewrite this, this is the integral of u to the 3/2 minus u to the 7/2, and then I have a du. Interesting. Okay, so then u to the 3/2, u to the 7/2, those are both pretty easy integrals to do, right? The integral of u to the 3/2 would be positive 2/5. Oh, whoops. I completely forgot. Derivative of cosine is negative sine. Sorry, there's a negative du here. I'm losing my mind. Hold on, we'll just put a negative right out in front. Okay, so there's a negative right there because there's, oh, it's not there, it's here. There has to be. So it's right there. There has to be a negative du, not that step right here. The sine of x dx is negative du. Sorry. So then it's negative, and then the integral of u would be u to the 5/2 times 2/5 minus u to the 9/2 times 2/9 plus c, which would be negative 2/5, and then u was cosine of x, so I can just write it as cosine 5/2 of x plus, because minus a minus will be plus, 2/9 cosine to the 9/2 of x plus c. That went pretty well with technique number 1 right here. So we're using technique number 1. Now let's try it with technique number, well, let's figure it out. So here I have m is even, n is odd. So you can see n is 5 right here. N is 5, which is odd. So that means we're using technique number 2. Okay, so technique number 2 says split off a cosine of x and rewrite the resulting even power of cosine of x in terms of sine of x. So using Pythagorean identity, and use u equals sine of x. Okay, so let's rewrite this. So I'm going to take my cosine to the 5th, and I'm going to break off a cosine of x. So there's one cosine of x, and then I still have my sine squared of x, and then I have cosine to the 4th of x left over, dx. Okay, well, cosine to the 4th is cosine squared squared. So this is the cosine of x times the sine squared of x. And then this is the cosine squared of x squared. Now, why did I do that? Well, because then I can use the Pythagorean identity on that piece. So I can rewrite this as the cosine of x, sine squared of x. And then we rewrite this piece as 1 minus sine squared of x squared dx. And again, that's Pythagorean identity. Okay, so now it's said to let u be equal to sine of x. So then du, now I'm going to get this right. I forgot my negative in the last one, but this one doesn't have a negative. The derivative of sine is cosine. Okay, so this is the integral of, all right, if I make sine equal to u, that means this is u and this is u, right? So I'm going to have u squared times 1 minus u squared squared. And then the cosine and the dx are my du. Okay, so this is the integral of u squared times, and then I'm going to FOIL this. This is 1 minus 2u squared plus u to the 4th. Just a little distribution, which is, now I'm going to distribute again, u squared minus 2u to the 4th plus u to the 6th du. Right, just distributing my u squared to all three of those terms. And now I'm finally ready to integrate. So that's 1/3 u to the 3rd minus 2/5 u to the 5th plus 1/7 u to the 7th, plus your constant of integration always, which is, and now I can put back in what u was. It was sine. So I have sine cubed of x minus 2/5 sine to the 5th of x plus 1/7 sine to the 7th of x. So techniques number 1 and 2 are very similar and not too difficult to use. Seems all right. What about technique number 3, you ask? Well, you'll have to wait until the next video for that one.